we're beginning from where we stopped the last time. So far, we reiterated what we learned before. And from today, we'll begin to talk about functions. I think basically we'll now try to be giving ourselves exercises that will help us to maybe practice what we're dealing with. Now, functions. What do we mean by functions? In programming, a function is a block of code designed to perform a specific task. A block of code that is designed to perform a specific task. We use function for the sake of what we refer to as modularity. Modularity is the concept of dividing a big problem. The problem is large. We may not be able to address it, jump into it, and begin to address it as big as it is. So what we rather do is that we divide it into bits and chop it in that manner, solve problems bit by bit, such that when it eventually comes together, it gives a general solution. It's a concept tied to what we refer to as divide and conquer. Divide and conquer. So in divide and conquer, you have a big problem. Like I said, you divide it into modules and then solve that problem. So when you are doing this in Python or in other programming languages, what you do is that you write the block of program statement that is expected to perform the operation somewhere, and then you now write another part that now does the calling of the function. So for example, what we have here, what you now need to know is that in Python, we define a function beginning with the keyword def. We define a function in Python beginning with the keyword def. Now, the def keyword indicates that a function is being defined. The next thing that follows is the name of the function, like we have here. Hello is the name of this function. Hello is the name of this function. Now, in parentheses, we will now have, if there are parameters, we indicate them in this place. But when there are no parameters, we can leave it empty like what we have here. Then you have colon. Now, after this colon, when you press enter, computer will naturally indent. Python will naturally indent, hoping that all the things that are written within this indented area are a block of codes that are within this function. So for this very one, we have just a single line that simply says return hello. Return hello. So this one I highlighted is what we refer to as the block of code that is going to be executed. So when it is executed, whenever this function is called, something happens. So the next thing, I want to run this cell. When you run this cell, nothing happens because the function has not been called to play its role. Now, let us now go down to the next cell. Remember, this is a markup. It's just telling us what is happening. So we use the return keyword to actually call the function, return the value of the function. Now, in this case, now what are we trying to do? We want to call the function hello. And when we call the function hello, we assign it. So we assign it to the variable result. We assign it to the variable result. And then the next thing we do, we now implement result. And when we run results, something happens. So I've run this one, nothing happens. If I also run this one, what happens is that this function is called and its output is assigned to results. So the next time you ask computer to print results or you run this result, it now prints this hello word, which is what is returned. Now, we'll see further illustrations that will help us understand this deeper. However, we've been working with functions. Even one of the first illustrations we did here was more like a function. But let us look at a new function now. Now, but in this one, we are trying to say that when you call a function, when you define a function, if there is no keyword return within it, that function performs its function but does not return an answer. So because it does not return an answer, what Python returns is the variable or data type we call none. So it will return none because it has not been told to return anything. So for example, we have def empty, and here we say x is equal to 3. In fact, if you like, do a very serious mathematics here. Say f to the index 2. X is 3 to the index 2. This is a good mathematics. We've done it. Yes, something has happened here. However, when we run this function, and we ask it to print result, we see that the answer is still none because we did not tell it to return anything. So if we want it to return x as an answer, what we would have done is, if I say enter here and say return x, so the next time return x, I've written that. So if I run this cell now, run this second one, and run this third one, it now returns 9 because 3 to the index 2 is 9. Because we have asked it to return something, it now returns the value 9. I hope that is understood. The return keyword is what I've deleted the return keyword so that this notebook remains without being tampered. I mean, the knowledge still stands the way it is. So all we try to illustrate with that is that when you do not use the return keyword within a function, the function performs whatever operations it's been given, but does not return an answer. So there are moments when you want functions to carry out functions or do some things without returning answers. In that case, you don't need the word return. But if you want answers, then you need the word return. Now, the next part of function we want to treat, what we are doing here is summarizing Python. I don't know. These things are way deeper and deeper than this. I intend to maybe share my notes with us. I'll share my class notes with us so that we can use it and take these things a little bit deeper than how they've been presented in this notebook. Now, here we have receiving parameters. When you want to give somebody a job, most times, you would like to give the person specific instructions and most times give the person a tool to work with. Like the last time we had this meeting and we're being interrupted because I was using my own tool. And today we've been given a platform that will allow us to run the complete 2 hours without being interrupted. And that is a tool. So if you want to give somebody a function, you give the person a tool. And that tool you have given enables the person to carry out the function adequately. So that's what it is like in programming too. So for instance, you want to create a function that adds 2 values. To create a function that adds 2 values, we are just doing very simple tasks. Functions usually perform serious tasks like this. Perhaps we will experiment, we'll work with some of them so that you see. But here, we want to add 2 values, x and y. So we say def add x, y, return x plus y. So if we run this, it means we now have a function that has the ability of adding 2 values. So in the next cell, we might now decide to say result is equal to add, providing you now need to provide the 2 values. Assuming I remove these 2 and these 3, what it means is that I've not told the computer the two values I want it to add. So assuming I remove this and run this, you see an error. It's telling you that the function requires two positional arguments that has not been provided. So those two positional arguments can now be provided. So let's provide them. So we can say we want to add 12 and 12 comma 52. So any two values we provide, if we now run it, the computer now adds 12 and 52 and prints the result by virtue of this statement. So here now, we have told it what to do. Now, a function can actually be used in an expression in a manner that you can say, add this, let me reduce the value so that we don't start building, okay, add 12 to 2 and multiply the outcome of that addition by 3. So this time around, results gives you the whole of this expression. So what am I saying here? An expression that should return what this whole expression does, not this one, what this whole expression add this, what this function I called here does, what it returns basically is the outcome of adding 12 to 3. If you add 12 to 2, that's 14. So 14 times 3 is the 42 you have. So what it simply does is to add the values and return whatever the outcome is within here. It returns whatever the value is within here. If you want to see that in action, I can add a new cell here and we see that in action. So if we ask it to print, add bracket opens 4, 5. So that it adds the two of them and prints 9. So what have I illustrated here? That when you call a function, whatever is the value that comes out of the expression that is assigned to return is what it returns. So if it returns an integer, that integer can further be used for other arithmetics like what we did here. I don't know if we're following. I intend to find out if we're following. Any feedback? Not getting any response. Are we following?
Yes, we are following. It's a good luck.
We are following, sir.
Okay.
Maybe you put it in the question form to solve. That's the reapplication of this thing. Because you are doing it now, just the reapplication. Okay. Where do we apply this thing now, sir? Please.
Okay.
Thank you, sir.
All right, thank you. What we're still trying to do here is to build background of, we are building background, teaching us the concepts and tools you have in Python that can enable you to solve problems and perhaps do your data analysis when the time comes. So let us, okay.
I don't know this already. Michael.
Let us
he knows this thing. Him.
Let us take a
yes. Say I've done this thing that teaching now. I have done them before.
All right, ma. I think you might need to mute yourself because once I hear any voice, I get distracted. Let's take a task. Let's take a task. Supposing, let me create a new notebook now. This is Explore. I click plus. So I can say exercise.ipynb. I said the other time that this is what makes the file you are creating to be a notebook. Otherwise, it could be a regular Python file. Okay, so in this new notebook, we want to take a simple task just to carry us along. And that task is the task of let's say finding the area of a circle. To find the area of a circle, let's assume that is the task we have created for ourselves now. Okay. Now, what is the area of a circle? I will go back to this marker. Let me go back to this marker. What is the area of a circle according to mathematics? We are taking up a problem now. The area of a circle is equal to 2. How do I represent pi now? 2 times pi. Let me use the spelling pi times r squared. So maybe we should have learned some things before getting to this. But 2 pi r squared, or 2 pi d, that is the diameter. So now the constant in this formula is 2 pi and perhaps the squared. Why r is what varies in the area of a circle. So if you are given this task to do in Python, how are you going to face it? Let me turn this to Python instead of this. Okay, instead of Markdown. Okay, now to face this, the everyday Python person is going to jump into this and say, first, and there are several patterns you might use to do this. You might request that the user enters the value of R, or you might assign a specific value for R. So since we have learned how to name a variable, we're going to name a constant and a variable. So the first constant we're going to name here is pi. So what is the value of pi? Pi is equal to 22 divided by 7. I know we are science people, so 22 divided by 7 is what pi represents. We've assigned 22 divided by 7 as a constant to pi. Then we now also assign r. So let's assume r, the value of r is 20. Now, the next thing is how to now get the area. You now say area is equal to 2 times pi times r to the index 2. So let me be adding comments for explanation. So what we did here was to assign variable. Now here, I can just say find area. What we did here was to find area. So now let's print the value of area. This is comments I'm adding now. Display area. So how do we display area? We use the keyword print. Print is also like a function, but it's among what we refer to as predefined functions. So print area. So we can just say area here. Now, if you run this, connecting to kernel, we've not been running this now. So if you run this, the value you see here is the area of the circle whose radius is 20. So if we change the radius to 5 and run this again, the area has changed. The area have changed. Now, the next time you want to find the area of a rectangle, you might need to rewrite these codes. So let me re-explain. In fact, let me take some time. In this example that I've done now, what are the things we've learned so far that I've tried to relate? Number one is that I try to show us comments once more. With these comments, I'm explaining what each part of my code does. This is what comment does for you. If we have noted that, the next thing I've been able to illustrate with this example is that I can assign values to variables. So the assignment term, the assignment operator is equal to, in this case. So once you say equal to, whatever expression is on the right is assigned to the value on the left. So we have assigned 22/7, which is an expression, to a constant pi. So that when next we say pi, the computer knows what we're referring to. We equally assign the value 5 to r. R here stands for radius. You may decide to write it in full. You may decide to write it in full. Now, how do we find area? We find area by using the variable area equal to, we now write the expression that generates area. So this expression I wrote here is universal. Everybody that learns, or everybody that is bothered about getting the area of a circle will get to know eventually that it is either you use 2 pi r or 2 pi d, which is the diameter, 2 pi r square rather, or 2. Now remember that r is half of the diameter. And when we say diameter, we mean dividing a circle into 2 equal parts. That is what the diameter of a circle is. So you draw a circle, you draw a line in between it, 2 equal lines, dividing it into 2 equal parts. That's what it is. While the radius now is like getting the center of the circle and drawing a line from that center to any edge of a perfect circle. That's what it is. So what in a nutshell, r squared is the same thing with d. So I'm not teaching mathematics. This one is an existing mathematics principle. So if you say area is equal to 2 times pi r squared. I don't know if this formula is wrong, then whatever answer we're getting here might just be wrong. But this is this. This is it, how to calculate things like this. So if it were to be area of a rectangle, it will simply be length times width. So whatever it is, we assign it in this manner. And now, what did we do here? We called the function print, which is a predefined function. We did not have to write it. That's what we mean by predefined functions. We have predefined functions. We have user-defined functions. User-defined functions are those ones we write ourselves, while predefined functions are the ones that have been defined and included in Python or in other programming languages. All you need to do is to call them and they come in and perform their operation. So print is one of them. So when you say print area, it just produces the value of area. So if you also want to add flesh to this, in order to explain further, you might say area is, so that it will be explanatory. So area is, now prints the value of area. Or area is equal to, or whatever. So I've written a string here now that is just printed. And so these are the application of some of what we've been learning. But we are trying to do what we refer to as a crash course, kind of crash course in Python. So we're rushing or brushing over these things. If we decide to take it slower than this, it will only cost more time, and that's all. So online like this, I don't know how comfortable we feel digging deep and deep and deep. So if you are really deeply interested in Python, by the time I share the notes, you can work with it. However, we'll later get to deal with, what do you call it? We'll later get to deal with the data analysis part of it. So now the last thing we want to talk about in function is that when you pass arguments in functions, unlike here, if you pass only one argument here, this function will not work well. If you pass 3 arguments, it will not also work. If you pass no argument, it will not. At least we saw that when we ran it without including an argument, it gave us an error. So, but here we have devised a means of defining a function that will have a variable number of arguments. So we just want to add any number of values we provide within this place. So if you say 3 values like this, it will add them. If you say 4 values, assuming I decide to put comma again and say I want it to add the value 4 to these ones. So if we run this now and come and run this, it has added all the values we have here. So multiple values. Now, how did we achieve it? We achieved it by using asterisk args. Asterisk args. So asterisk means multiple number of arguments. And here we now decided to call another function. If we want to code this ourselves, it will involve a whole lot of things. We will need to increase the size of this function, and it might eventually become complex for someone like those coming into Python. So, because what we're doing here now is part of what we refer to as object-oriented programming. So, this is like a class, and we are providing it with the attribute of OOP we refer to as polymorphism. So it should have the ability of performing different tasks depending on the number of parameters that are given to it. So, but that's by the way. So we decided to call another function sum, so that once this comes here, it will go and call sum will come and add it for us and give us answer. But that's by the way. All we need to illustrate with this is that you can do this for any number of variables. So here we have asked it to add 1. Add 1, it adds only 1 and returns the value. Okay, now we go back. We are done with the approved version of what we intend to show us in a function. So funny enough, all what we wrote under here is always one line of statement, one line. But when it comes to function, all what I've written in the previous, this thing can be done under a function. Yes, let me go back to that exercise we just did here. So if we want to make this function, this block of codes, to operate in a manner that you can call it whenever you want to get the area of a function, of a rectangle, of the area of a circle, and it will implement and give you an answer. We can copy this code, place it under a function, and that will happen. So let me quickly copy this, Control X to cut so that it disappears. So I've cut it. So the next thing I do is I say diff. I may decide to call it circle area. Circle area. Bracket opens. We'll be needing an input. That input is R. That will be the parameter we will require, because every other thing there are constant, but R is a variable. Okay, so we can do this and press enter. So we paste this. And in a case like this, we no longer need to declare. R, because we want this thing to be running as many times as we desire. The issue here now is that Pi needs to, all these ones, they need to be indented, because that is the only way Python will understand that they are under this. Okay, now, the next thing we need to note is that there will be no need printing here any longer. What we will rather do is to just return the value of area. what we just need to do is to return the value of area. So instead of, we don't need to display it again. And we might choose to assign it this way, and now let us say return area. Or we carry this expression and put it under return area. So what I've done here now is that I've specified this function such that whenever I wish to call it, I can choose to call it and computer will implement it. So let me go down and call it here. So how do we now call this function? We can just say print area of the function. We'll call it circle area. Circle area. Now, but before that, we'll need to provide the value of that circle. So what will be the value of this circle? The value of radius rather, so that it will get it for us. So how do we get the value of radius? We might decide to get radius by doing input. We might decide to get radius by using an input statement. Say input, brackets opens, we say enter the radius of the circle. Okay, when you do this, the computer will call for this, and when it comes out, you might decide to store it in radius. So if you say radius is equal to whatever input comes from this, then you now use it to call this function, and you have an answer. So let's quickly run this now. Control Enter to run. Now, when you run, there is this part that appears to be hidden here now. It says enter the radius of the circle. Okay, then it has scrolled up. So the radius of this circle, assuming it's 12, I type 12 and press enter. It uses that radius, is displaying an error. It should use that radius and pass it as the value of R here. And then returns area. So let's see what the error is saying. Unsuspected operand, asterisk, string and integer. Okay, so let's quickly convert this. We equally learned about this. Let's convert this to integer and see what happens. What did I do? I used int. Remember, we equally learned about this. So I used int to convert whatever input is coming in into an integer, then pass it to radius. And let's see what will happen. So I will run this again, and it's asking me to enter. Let me use the same value, 12, and press enter. So it now gets the answer of the radius for us. So you now get the answer of the radius. So if you want to be more self-explanatory, we can say the area of the circle is, so I've included a string that will help add some meaning to this. So if I run again, oh, sorry, I need comma here. If I run again and enter the value 4 as my radius and press enter, it now gives explanation. The area of the circle is, then it prints the area of the circle here. So this is it. this is it. Now, what it means is that whenever I want to get the area of a circle, all I need is to call this function. Within any block of code that I've copied this, within any block of code that has access to this function, if I go to the next cell, if I go here, let me make this a Python code to instead of a Markdown, converting it to Python. Okay, now if I come to this place and instead of asking for input, I decide to just say R is equal to 24. And then I put this, passing the value of R. So passing the value of R, if I run this, it calls that function and gives me this answer. So calling a function makes for what we refer to as reusability. It promotes reusability. There are a lot of advantages of a function in Python. So this is it. There are a lot of advantages of using a function. Part of them is that it makes for reusability. Another advantage of using a function is that apart from usability now, it helps to break problems down into bits, making them simpler to be solved. Another advantage is that it helps you to trace error. The way we wrote part by part, if you find error within a certain function, you just go straight to that place and solve it. Rather than some programming languages like HTML, if you have seen a code for a web page, you see that almost everything intends to be prefers to be written on one big page. But in modular programming languages like Python, you rather break these things into modules. So back to our lecture now. That was it about functions. I hope we're still here. So now we'll be looking at operators.
We are here.
All right.
We are here.
Now, okay. So just like when we worked with Excel, we try to understand the operators that are involved in the arithmetics we do, because as data scientists, definitely there will be calculations in your business. So the classification of operators we have in Python include arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, bitwise operators. Now, these are different types of operators. Arithmetic, we are very familiar with it already. We have the plus, minus, division, modulus, and so on. Assignment is, the chief among them is the equal sign. But after the equal sign, we have other assignment operators that combine arithmetical operators with assignment operators, such that when you say plus equal to, assuming you say age equal to age plus equal to 5, means add 5 to the value of age. So that's also an assignment operator. We have comparison operator, greater than, less than, equal to, not equal to. We have logical operators, and, or, and so on. Then we have identity operators, which is, in. You want to check whether something is equal to the other, use the word is, use the word in. Membership operator, I think membership operator is rather where you have in. Bitwise operator, and so on. Now, let's illustrate some of them as you continue to flow in data analysis, you see more of them. Now, if you want to add 3 to 3, the operator that should come in between is plus. So 3 plus 3, the answer is 6, like you know from everywhere. Okay, now if you want to add, so plus, minus, division, they work the way they ought to work. So allow us to use other things that might be of interest. So division is this division is this symbol. Multiplication is asterisk. Which other one? Minus is hyphen. So whether I say plus, let me just put values here. Okay, 3 divided by 2, or we can say 6 divided by 2. If we say 3 times 3, if we say 25 minus 5. Okay, now these arithmetics do exactly what you think they should do. They do what you expect them to do. So you don't need to dwell on it. Now, but let's look at this one. Modulus. We use percent sign to represent modulus. Remember in Excel, we're using this percent to achieve percent, but in Python, we're using it to achieve remainder. So if we say 11 modulus 7, what it will do is it will divide 11 by 7. And instead of giving you the quotient, it will rather give you the remainder. So 11 divided by 7 is 4. 11 divided by 10, so that you understand it, I run it, is 1. 20 divided by 10 will be 0 because there is no remainder. Okay. So what if we say 2 divided by 10? It will remain 2 because it will not be able to divide it. Okay, so, but if we say 25 divided by 10, it will be remainder 5. Okay, so let's still return it to the simple value it used to be, 11 divided by 7. What are we trying to say here? There are situations where what you want to get is the remainder of a value. That's the symbol that we use. Now here we have asterisk, as in double asterisk. That's what we have here. If you type asterisk twice, and what does it give? It gives raised to power. So if we say 2 raised to power 2 is what? 4. If we say 2 raised to power 3, we get 8. 2 raised to power 4, like we had here, 16. So how do you achieve this? It's typing asterisk twice. I just want you to see asterisk, asterisk. So, but in Excel, remember, we're using caret, shift plus 7. In Visual Basic, that's the same symbol we use, caret. But in Python, remember, we use asterisk, asterisk to represent this. Now, in Excel too, we learned about the precedence that is used in the arithmetic operations, trying to make us understand that 3 plus 4, which should have been 7, times 5, which should be 7 times 5 should be 35. If you run this, it gives you 23, which is not what one may expect. So, but just bear in mind that the order of evaluation does not necessarily go with the order of appearance. Rather, it obeys BODMAS. This is common in arithmetic, and we emphasized on this during our Excel class. So that knowledge is transferable. If you want to do an arithmetic such as this, it is better to be explicit. Open brackets here, close brackets here, so that it now knows that clearly you want to add 3 to 4 before multiplying it by 5. Otherwise, it will rather go and, the way it was, it will rather go and add, it will rather go and multiply this by this, getting 20 before adding 3 to it. And the human eyes may not be that sharp, especially when you have left secondary school several years and you're no longer dealing with BODMAS. Okay, now very quickly, here we have an extension of that, indicating that as star is, that exponential is treated first before multiplication. Oh no. Exponential is treated before multiplication, while multiplication is treated before addition. So that is what this illustrates. So here you have 2 to the index 3, giving you 6. 6 times 4, giving you 6 times 4 will give you 32. Then you add 3 to it and you have 35. So that's it. Then here we try to illustrate Boolean operator. Boolean operator is used in logical expressions like we said. So when you say 7 is greater than 3, that is correct. So it returns true. Well, when you negate that, let me add a new cell so that I can illustrate this one. If you say 3 is greater than 7, and you press enter, what you rather see is false instead of true. So when you have this in a logical operation, the decision of what happens thereafter is determined by whether the outcome of that expression is true or false. Okay, again, we have here 8 is greater than or equal to 2, so that we can remind ourselves that greater than or equal to, which we saw in Excel, also exists in Python. Greater than or equal to, less than or equal to, greater than, less than, not equal to. They apply to Excel the way they apply in Python. Let me just confirm this, please, before I... If it were in Excel, this will represent not equal to, but in Python, I think I will have to try a few things because I do not readily remember. Let me see whether this works. Yes, not equal to. So if you say 8 is not equal to 8, it will tell you false. So to get not equal to here, instead of using what I just did, if it were in Excel, what you would have done is greater than or equal to 8. Since it is Python, what you do is you use exclamation mark before equal to, and that represents not equal to. So this is wrong. Let me just make it a comment. Excel syntax. So, but Python will use this approach. Okay, now, the next thing is a not supported between instances of integer and string. So you are trying to compare 8 to ABC. In fact, even if you put 8 here, if you compare it, what you find here is an error because as a strongly typed programming language, it cannot afford to compare them. So even if you say you ask it to compare, let me illustrate this. If you ask it to compare 8, whether 8 is equal to this type of 8. So this one is string. The other one is sorry, this is not what I want. Sorry, to compare this rather is equal to. Thank God I even reminded myself. Okay, now 8, if you say 8 is equal to 8, it says false. Because this one is string and this is string and this is integer. So what it is rather trying to check is whether they are the same object. So if they are not the same object, it tells you that the answer is false. All right. Now, this one now is helps to remind us of logical operators. Here you say true and true is true. True and false is false. False and true. So this one is simple logic. If you study computer science, you come across this again and again. So if we say true and false, it is false. False and true will still be false. So the only thing that functions together and returns true is true and true. But when it comes to not negates whatever you give it. So if you had false, if you say not false, it will give you true. If you have false or true, it will give you true. False or true will give you true. True or false will give you true. True or true will give you true. It's only false or false that will give you false. These are things you can look up on tables that exist for that purpose. I have this ambition of rounding up with this today. I mean, the introductory part of Python in today's class, but looking at what is left, I'm a little bit scared whether we can cover this in 20 minutes. So there is no need expressing this my target will almost not work. Okay, now this is it about this. We've been able to illustrate that operators such as these logical operators or and not, and they play this role. If you want to understand how they play out, you can implement, you can check it up on the internet. I think there are standard tables that describes this. There are standard tables that describe this as logic, and it's the same thing, I think, both in English, in mathematics, in electronics, and in programming. Those rules of true or true being true, true or false being true, false or true is true. Only false or false is false. Then you go to and. For all possible combinations, it will always be false except true and true. So true and true is true, but true and false is false. False and true is false. False and false is false. While the negation, gives you the other one. So we have about 20 minutes to end, and I would like to take our consigns before we round up, so that in our next class, we look at control flow. If there are questions, please. So if you may unmute yourself and ask your question. The benefit of being live is that you can actually draw our attention, ask the questions of interest so that we can address them. You can equally make comments that will guide us. If you have any question, we have gone through operators, we have gone through.
Yes, sir.
Yes.
Yes. Thank you. Well done for the lecture. For me, this last part I didn't really get. The Boolean equation part. I was trying to get it to catch what you were doing. I didn't really get it. I got from the point of the Python, the initial equation, the one with the area of circle. But when we got to this part, I didn't really catch it very well. So I don't know if you wouldn't mind to go into it a bit so that it's a bit clearer. And also I wanted to clarify, for area of circle, I don't know, I was thinking it was, I don't know if you just use that formula just for illustration. I was thinking it was pi r square, then circumference is usually the 2 pi r.
2 pi r. Thank you very much. You know, along the line, I started suspecting my formula, please. The idea here in programming is that we use real life principles to solve problems. So if this is going to be applied in anything, it has to be correct. So forgive me for bringing in that constant too. So whatever the correct formula is what it should have been. So what I have to now do is go back and debug. That's what we do in programming. So if 2 pi, pi r square, yes. In that case, I remove the 2 pi. So
yes, sir.
This solves the problem. And it's actually, thank you very much. It's actually another benefit of having your programs in functions. Yes, using functions, that's modularity. What I've just done now has corrected what we have here. It will correct whatever we have here too. So I just hope did I run this again? I'll first run this. Then, okay, this one is expecting me to make an entry. So I should come up here and make this entry. It's asking for, let me enter 12. I don't know whether it's active. Okay, so that it gives us what it is. Okay, so just to be very sure, I'll run this again. And then run this again. Okay, so whatever we have done now, if this is the correct formula, that is what it should be. So whenever you have issues like this, definitely you have a duty to do what you refer to as system analysis. You find out what it is, the problem you want to solve. You don't know the root of the problem, definitely you commit errors like the one I just did. So the correct formula is what works. I should also correct that in my markdown here. So thanks for that correction. What we should now do is, I would like us to go back to the area you said you did not quite get. Let me try to explain it again. I'm trying to edit this markdown so that it doesn't create a error. So, and let me also add this term. What we just committed now is what we refer to as semantic error. Semantic error is that type of error that you commit by virtue of bringing in the wrong logic, like you are using the wrong formula. So the computer will run, your program will run, give you an answer. But the answer it has given you is not semantically correct. So what we have gotten here have not been the area of a circle so far, but we have been boasting that we got the area of a circle because our logic, our formula was not correct. But syntactically, the program we've written is correct. And whatever syntax we are trying to teach still stands. Okay, so now back to, thank you very much once more, Sandra. Back to the question you just, the area you wanted us to point at. What we are trying to illustrate here are operators that exist in Python. The essence of telling us about these operators is so that we know how to build expressions. So that we'll learn how to build expressions. We are building expressions in Python, in Excel. We built expressions, DAX, in Power BI. And of course, analysis cannot do without expressions. Analysis cannot do without some level of mathematics. Of course, mathematics equally comes in statistics. It's on that note, we want to go through the operators that arise. We did not treat all of them here. As time goes on, when some other ones occur, we will try to look at them. However, the note I said I will share with you may not necessarily be this book, this notebook here. But if I share that note with you, if you look through it, you will find details. That's the note I use in my class. Remember, we do Python for an entire semester. So in that note, you find details of all these and their illustrations, no matter how short. But looking at the one I'm doing now will be a closer guide. On that note, I'm sure, Sandra, if you will unmute yourself, I would like you to give
Yes,
a quick response. You understood the part of arithmetic operators, right?
Yeah, a bit, yes.
They are common. They are common. Okay, now, assignment operators, I did not illustrate them, but I said something about them. However, I may choose to illustrate them very quickly. Let's say you are writing a program that will calculate somebody's age. If you write a program that will calculate age, that program that will calculate age from date of birth should be such that every year it should add one, it should put a plus to whatever the age is. Or okay, rather, no. This might not be the best illustration because to calculate age from date of birth would be best that you compare today's date with the date of birth and whatever outcome gives you that. So that may not be the right illustration. But okay, a right illustration might be a situation where you want to loop. Let's say I want to write a program that will print a value 3 times. A program that will print welcome 3 times, for example. So if I say welcome, so the statement is print. So if I run it, it prints welcome once. But supposing there are several other ways of getting this actually. Well, supposing I want to do some form of looping that will repeat this statement 3 times. I may decide to use, that will be another complex. It's actually the part I opened. It's actually the part I opened that we're supposed to enter next. I do not intend to be busting our minds ahead with deeper things that have not been treated while trying to illustrate a very simple concept. A very simple concept. let's just illustrate it with this simple term. Say age is equal to, I did this before. Let's say age is equal to 20. Now, assuming we want to say increase the value of age by 1, we can actually just say, so if I print age, it gives us 20. Now, if I create a new cell, and inside this new cell, I say age is plus equal to 1. If I print age again, you now see that age is now 21. Age is now 21. So now, a symbol like this one here is an assignment operator. Is a special kind of assignment operator. There are other examples of this type of assignment operator, such as other examples of it. Let me use a markup. Other examples of this type of operator is we have plus equals, we have minus equals, we have multiply, that is times equals, we have divide equals. So what do they do? What they just do is that the expression on the right is added to the variable or minus or divided by the variable on the left and still stored on the variable on the left. So here we say we add this one to age and still store it in age. This would have been explicitly written as age equal to, some programming languages will write this as age equal to age plus 1. So let me comment this out so that it doesn't look like a clash. So this is how Visual Basic, for example, will handle this. So this is assignment operator, and these are the other examples of assignment operators. These are the other examples of assignment operators. Okay. Now, after that, we talked about precedence. Now we talked about Boolean operators. I want to believe you also understood Boolean operators because the symbols are the same, except for not equal to. So we still have plus, sorry, we still have greater than, we still have less than, greater than or equal to. So you use this to compare two values. Or in fact, it can even be variables. You say x is equal to 20, y is equal to 24. Later, you now say, if x is greater than y, do this. If y is greater than x, do that. That is what comparison operators can look like. However, we now later went to the one we call logical operator. This is still comparison operator, but this is logical operator. Now, in logical operator, we usually try to compare, or rather combine, build what we refer to as complex expressions or complex logical expressions. Now, when we say complex logical expressions, we mean there's an expression on the left, there's an expression on the right, and we now want to use a conjunction to join them. Now, what is the outcome of the conjunction? If the expression on the left is true and the expression on the right is true, what will now be the outcome? Now, maybe I should explicitly illustrate this. It will still lead to building a logical operation, which is part of what we're supposed to treat in the next part. However, all I wanted you to you don't need to, like I said, think so deeply about this, the outcome of this. Practice will enable you to eventually get so used to it. As from my year one, we're already dealing with this, and it was even occurring in different courses like linear algebra. You deal with it. Logic in English, we dealt with it. Programming, we dealt with it, and then we still dealt with it in logic um, what do you call this course now? Electronics. That's computer electronics, something like that. Now, all it. So what I'm trying to say is that trying to cram that what we refer to as truth table may be out of place, may not be too wise, may not be too wise at this point, because with the power of the computer now, you can always Google this to confirm. However, if you are involved in any calculation, if you are involved in any system, you are building any system, and you come across scenarios where there will be a combination of logic. Let's take, for example, a student applies for admission in a school. The conditions for the student gaining admission into that school may be one, that the student must pass JAMB. That's the student must score, let's say, 200 in JAMB. Two, that the student must score, let's say, 100 in post-UTME. And the student must be at least 16 years. I think I know about such a rule in Nigeria. And the student must be 16. Now, the relationship between these three conditions is and. So if the first logic, when you now want to test these conditions, what are you going to test? You say, is student's JAMB score greater than, is JAMB score greater than 200? And post-UTME score greater than 100 and age greater than 16. So these three conditions must be true, otherwise the students will not be admitted. So what we're now saying is that if the first one evaluates as, assuming there are only two, like in polytechnics, for you to pass a course, you must have a score in practical. By that, I mean, even if it's 5, I think for some schools, even if you score 5 over 30 in your practical, in some courses, it's now 20. So assuming you score 5 or even 2 over 20, the student in practical, the student is still likely going to pass if the combination of the student score is over 40. So on that note, for a student to pass, you will say the condition is, pass condition will be that total score has to be greater than or equal to 40, and the practical score now, practical score has to be greater than or greater than 0. Has to be greater than 0. So this is the logic now. So if I want to, this I can say if bracket opens, this and this, then print the student passed. Okay, so all I need to do now is to provide the value of total score and the value of practical. And this will be a complete program. I've not thought us this, but so we will actually get to see it more. Total score. So let's say total score is equal to 45. In fact, let me even do everything here. We have exceeded our time actually, but let me see if I can quickly write this program. Total score is equal to, it will be practical score plus exam score plus test. Let me begin from test. Test score. Okay, I'm writing this program in reverse order. So now how do I provide these values? Let me just assign them. It would have been received through inputs, but let me just assign them. So I say test score. I rather copy this thing so that I don't waste time. Test score. As when you say test score is equal to over 20 if the person scores 12, and let me copy practical score. So assuming we say practical score is equal to 15, and then exam score. So if we now say exam score is equal to 27. So total score, I didn't spell this one well, total score is equal to this. Now, if you run this program, it is saying the student passed as the answer. The reason is because this expression here returns true. This expression here returns true. That is why the student passed. Supposing this one returns true and this one does not return true. Let's take, for instance, if the student did not write practical, that is how we do in the Polytechnic. So if you run this, we did not provide what will happen when the student did not pass. So he did not write anything at all. Okay, so we can actually provide that. We have almost done everything now. So let's say else. Let's say else. Sorry, I need to put column. Else print that the student failed. Okay, now if I run this again, you see that because practical score is 0, the student failed. Are we together? Now let's change this and to or and see what will happen. If we change the and to or, that means our combination now is different. We have now said once the total score is above 40. So to get total score to be above 40, let's assume that the student scored 30, 8 in exam, but scored 0 in practical, because the combining force is all, the student will still pass. And I think this might be possible in the university. I don't know. This might be possible in the university, that a student that scored 0 in practical still passes because the student's total is greater than 40. So once total score is greater than 40, the student should pass, irrespective of whether the practical score is greater than 0. Now, this might not be very real for any sector, because what this logic represents here now is that, assuming the student scores 3 in practical and scores 10 in the exam, meaning that the total score now has become less than 40. Because the combination force is all, because the practical is greater than 0, now it still prints pass. So all we are trying to illustrate here is that for a complex logic, you combine them using and or. And that when you combine, when the outcome of the one on the left is true and the one on the right is also true, that if the combining force is and, it will print true. But if it is true and false, it will print false. If it is false and true, it will still print false. If it is not false, it will print true. If it is not true, let's say not true. For this case now, it will print false. So all not does is to just negate whatever the outcome is. Whatever value it sees, it will just turn it upside down. But or is the operator that is used when you want to have true for all other conditions except when the two parameters are false. Or is used when, so or is used when you want to say true for all other possible combinations except false, except false. So the illustrations are enormous. Like supposing I give a gift now, I want to send to your office. I might write 4 names and say, if you see Sandra or Onyeka or Madam Francis or Bella, give that gift to the person. Or it might be a mail. Usually gifts can be personal, but let's say a mail that is meant for your office. So you just specify all these people and say or. So it will be true once. So the message you deliver, so long as any of these ports or any of these persons are available. But if that thing is such a thing that I need a witness, I might say, give this if this and these persons are in the office. Meaning that if you don't see 2 of them seated, don't give. Even if you see 1 of them, do not give that gift. Do not present the letter or document except you see 2 of them. So it's, as it applies to English, it actually applies to this logic. It's just that in English, most times we don't think so deeply about it. So, but it actually works the same way. And that is it. So as from next week, we'll be looking at control flows that will enable us to implement these logics. You will see a real application of some of these logics we are talking about. We see how you can control the execution of a program so that if this, else will happen. If this, do this, else do the other, and so on. Or we also look at conditions where you can decide to repeat a certain block of codes a certain number of times. That's what control flow is all about. And that is part of what we're going to deal with by next week. So if there are still people online, would like to get some comments before we finally log off. You're still online. We'll appreciate if you can unmute yourself and let us understand. If you still have any concern, all right. Thank you very much for attending. We will encourage you to use exercises to brush up what you know about this. And I always will encourage anybody I'm teaching, no matter the course, to dig for resources wherever you can find them. The objective is that this interaction is an eye-opener into what you can do with Python, for instance. So if you want to truly learn Python, please do not base all what you are going to learn from what I as a person is doing or what this platform permit us to illustrate to each other. So I show you possibilities. You go dig up materials from here and there and better your understanding on whatever I have tried to throw at you so that you can improve. Programming is not taught. If I say programming is not taught in class, I don't know what it will sound like, but that's the truth. Before one can become a programmer, they usually do independent learning. However, if you go trying to do the independent learning without first learning in class, it's not always that simple. So a blend of the class direction and then your independent learning will help a whole lot. So combine these demonstrative classes we have done like this with reading of extensive notes and also with resources you can find on YouTube and on any of these courses you may find online. They will enable you to grow in your programming skill. All we are doing here now is trying to establish Python so that as time goes on, we'll be able to now go deep into data analysis. And you'll see how we can use Python to do wonders, data analysis. So remember, we are targeting to deal with NumPy, Pandas, Matplotlib, and maybe any other library of interest that will enable you to get data, clean data, perform your aggregations, your analysis, and then visualize your data. Design the dashboards you want, and so on. So these are the things we are digging towards. Rather, at this point, we're just trying to arm ourselves with the skill of Python so that we'll be able to flow well. Thank you for attending. God bless you. Thank you for your time and for listening. And we hope to share these resources with those that are not in this class. If they are interested, you can always watch. And even you that have participated in the class, you can always go through it and see how much it can help you. Thank you. God bless you.
Thank you, sir. God bless.
All right. Thanks. Bye.